Okay, well, I can't believe that we're actually at the end of the course. This is the last section. What I'll do in this section is to just go over a summary of everything and give you a few ideas for where you can go from here. Okay, so there we have it. Course summary, hardware, software, expansion, some new ideas, some other projects you can look into, Tasmota Home Assistant and ESP32. Okay, so this is pretty much it. We used a D1 Mini with an ESP8266. So effectively what happens is this chip is put into this module is put onto this board, and this is the D1 Mini, which actually has almost a standard footprint, and then you have shields that plug in on top. So these are the two shields that we worked with, the DS18B20 Dallas semiconductor, and then your OLED shield. Alright, so this is a 64 by 48 pixel display. As you can see, both of them plug into a D1 Mini and interface to whatever pins are needed. Alright, and then what we used as a server was a Raspberry Pi, Pi 3B. We installed Raspbian on it, so that gives you your base operating system. Alright, then what we did after that is we installed Docker. Docker is a container management system, so the containers we then created, or could call them services as well, was Mqtt, which is an MQTT broker, Node-RED, it's like gives you flow management, flow control, or they call them flows, and then InfluxDB, which is a time series database, and then Grafana, which allows you to draw graphs and charts and dashboards. Alright, then from the D1 Minis we used ESP Home, used Visual Studio Code to actually write the code. These are YAML files, and then we used ESP Home, which takes the YAML file, compiles it, and creates a firmware file which gets uploaded via USB to the D1 Mini. These are some of the tools we used. So this is Putty, which allows you to SSH, a secure shell, into the Raspberry Pi. We then had Mqtt Explorer, which allows you to have a look at the MQTT messages that are going back and forward or from the devices. And then over here we have WinSCP, which we copied the files across. So we did step 1, step 2, step 3, step 4, Portainer, Mqtt, Node-RED, InfluxDB, and Grafana. And then once we sort of had a working system, we had Portainer, which was actually allowed us to see what was going on inside of Docker. So once again, this is sort of the dashboard and the containers. You can see status of how they're running, their names, what ports they're exposed on, and so very, very powerful tool, Portainer. Then in Node-RED we created some flows that allowed the D1 Mini messages that came through MQTT to get sent across to the OLED display. And then the other flow, what we did, we took the same MQTT messages and created an entry and posted it into the database, the InfluxDB database. And then ultimately this is the result. You actually have Grafana that shows you now a chart, and this is your graph showing your real-time temperature. Here I actually put it in the freezer a bit, and you can see how it went dipped and it came back up again. Alright, so some expansions where you could go from here. If you look on the ESP Home site, they have components, other display components. So you actually could essentially use like one of these dot matrix displays, or a TFT display like this. This is a e-paper display, so this allows you to now take the same information and display it on another node, on another little unit that you can put somewhere else in your house. These are the two sort of D1 Mini plugins. So that uses a Maxim chip, and then this is a TFT, which is a sort of a full color display. Alright, okay, and then some other projects that that sort of come along the same vein as ESP Home is this called Tasmota. Tasmota is being written to reflash Sonoff. You get these Sonoff devices, they are like Wi-Fi light switches and things like that. And these guys created firmware that allowed you to take the default firmware and reflash it with this Tasmota, and then it meant you could, you could include it into Home Assistant and things like that. You can see the same MQTT. It's got components, modules, peripherals, web interfaces, and all that type of stuff. So you should definitely look into this. And then of course Home Assistant. Home Assistant, effectively now works very well with Tasmota, as well as ESP Home. So the devices you created in ESP Home can actually send MQTT to Home Assistant, and Home Assistant can then show you the status of your lights and switches and stuff like that. Okay, then what you want to look, we dealt with the ESP8266. That was the original device that was released by Expressive. Expressive released another device a bit more recently, the ESP32, and this is sort of its big brother. This is a dual core processor, much more powerful. In fact, you get now a lot of newer devices that are now ESP. This has Bluetooth LE on it, Bluetooth Low Energy, and so this is now sort of what you have inside the chip. You can see it's actually really pretty amazing. You have Bluetooth, Wi-Fi, your normal Wi-Fi radio, and then you have a dual core processor, power management unit, ultra low power processor, so when it goes to sleep it can draw very low current. And then you can see the amount of devices, SPI, I2C. You can talk to SD cards, UARTs, CAN, Ethernet, infrared. Got PWM controllers, internal temperature sensor. You can use the pins for touch sensors. It's got a DAC and ADC, so pretty impressive, and a bit more expensive than an ESP8266, but I think the learning curve is a bit more steeper on this one. But it's definitely something, if you get familiar with the 8266, then you should really look at this chip. Alright, well, I guess that's the end of the course. I hope that you have learned a lot in the course, and I certainly hope to be releasing more courses in the future, and I hope to hear from you, and bye for now.